Hello, this is lesson 1.1. In this lesson, we're going to determine if numbers are rational or irrational. The center question says, how do I determine if a number is rational or irrational? So we have some warm-up questions here, and the question asks us, which of the following numbers can be written as a fraction? So this kind of gets down to the heart of what this lesson is all about. So maybe, hopefully what you found, is this number could be written as a fraction as 3 and 45 over 100. This one is already a fraction. This third number, we actually cannot write that as a fraction. It's impossible because this keeps going forever and ever and ever. And so as far as we know right now, we can't write it as a fraction. This third number, we will eventually be able to write that as a fraction, although it's kind of tricky. For those who might know already, it's 9 and 134 over 999. Don't care if you know it yet, we'll get to it later. And this last guy, well, he's already a fraction, so he doesn't change. So out of these problems, this guy and this guy could not be written as fractions, and that's going to come into play throughout this lesson. So we have two vocabulary words. First one is a rational number. A rational number is any number that can be written as a fraction. So all those problems on that first page that we were able to write as fractions, those are rational numbers. It says here including integers, repeated decimals, and terminating decimals. So there should be some commas in there. So integers would be positives and negatives, so you can have a positive rational number and a negative rational number. Repeated decimals can be turned into fractions, and terminating decimals can be turned into fractions. The other vocabulary word here is irrational number. And an irrational number is any number that cannot be written as a fraction. So that would be like those other two that we saw. This number cannot be written as a fraction. Actually, this can. So out of this page, just this one number, I'll circle it in red, that cannot be written as a fraction, so that would be irrational. The other four we're going to see are all rational. So in these first problems here, what they ask us to do says for each example, determine if the number is rational or irrational. The definition we said for rational is if the number is terminating or repeating. This decimal repeats 1, 2, 1, 2, 1, 2. It has this repeating pattern. Because it has a repeating pattern, this number is rational. And that's how we know. This is a repeating decimal. Letter B. Is this number rational or irrational? So you should be thinking to yourself, can we write this as a fraction? And the answer here is yes. You can write this guy as a fraction pretty easily. Any number, any whole number, to turn it into a fraction, you put it over 1. So negative 9 over 1 is a fraction, which means this number is rational. Number 3. I'm sorry, letter C. Letter C here is already a fraction, 3 over 4. Since it's already a fraction, yes, this number is rational because you can write it as a fraction. And letter D. The number pi, which actually is what this is, 3.141592753. It goes on and on. Well, this pi, we can't write that as a fraction. That number is literally impossible. This decimal, if you would look at it on computer or look it up on the internet, you would see it's a number that does not stop. It goes on forever. And it does not have a repeating pattern. Like this first number was like 1, 2, 1, 2, 1, 2. There is no repeating pattern that continues forever in pi. So this number is irrational. So that's how we tell. If you can write the number as a fraction, like letter B, it's rational. If the number is already a fraction, like letter C, it's rational. If the number is a repeating decimal, which means it has a repeating pattern, or it's a decimal that stops, like 3.5, that would be a rational number. Next page. Now here we have some uglier numbers. We have square root of 30, and we'll get to that 0 in a second. So let's look at this square root of 30. So square root of 30, if we would take the square root of it, well, let's go ahead and find ourselves a calculator. There we go. So I'm going to type in 30 square root, and it gives me this number, 5.4772255750516661. That number, as far as I can tell, does not have a repeating pattern. And it doesn't look like it stops. I mean, this goes, it's a long way. This square root of 30 is also irrational. It is a number that cannot be written as a fraction. Well, how can you tell? How do you know it doesn't stop or doesn't repeat? The trick here is with square roots. If it's square root of something that, if it ever comes out to a decimal, it will never work. So if you take, for example, the square root of 9. The square root of 9 square root, is 3. That did not come out to a decimal. That number would be rational. But if you pick any other number, for example, 8 square root, that decimal won't stop, and it won't repeat. That would be irrational. Pick any other number, 15 square root, doesn't stop, doesn't repeat, it's irrational. For those of you who know this phrase, the numbers are rational if you're taking the square root of a perfect square. 9 is a perfect square. If you don't know what a perfect square is just yet, that's fine. We'll be going over it here shortly. So now, I would like you to look at this letter F, 0. Do you think 0 is rational or irrational? Can you write that as a fraction? Is it a terminating or repeating decimal? So take a second or so, try it out. Okay. Hopefully you said that 0 is rational. It is, because I could write this as a fraction, 0 over 1. It's also a terminating decimal, 0.0. So these are all different ways to show that this number is rational. Now, out of these next 4 problems, what I'd like you to do, I'd like you to pause the video, try these 4 problems on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, let's see how you did. Letter G. Letter G, you should have said, is rational. And it's rational because this is a terminating decimal. It stopped. It doesn't keep going forever and ever and ever. It's done. So it's rational. Letter H. This number is rational. And you can tell because, well, it's already a fraction. And you can make it, I mean, it's a mixed number. You can make it more of a fraction if you, 2 times 1 is 2, plus 1 is 3 over 2. That's an improper fraction. Or 1.5 as a decimal is 1.5. Those are all different ways of showing this same number. This 1.5 is 3 over 2, and it is 1.5. All of them show you that this number is rational. Letter I. As far as we can tell, this number doesn't seem to stop. That's what the dot 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 means. It means it keeps going. And it doesn't have a repeating pattern that we can see. So as far as we can tell, this number is irrational. Letter J. Square root of 19. Well, let's take a peek-see here. 19 square root. Big ugly number, which means irrational. So, rational numbers you can write as fractions. Irrational numbers you cannot. So, example 2 here says we're going to write all rational numbers as fractions. So every one of these numbers we're going to get now, we're going to show you how it can be written as a fraction. So the first one, super simple. Anytime you have a whole number, to turn it into a fraction, you put it over 1. So this 8 as a fraction is just 8 over 1. Super easy. Letter B, 3.56. Now, there's a couple ways of doing this. One way is that you can read it the official, and you can't see me doing air quotes, but the official way of reading that number, which is not 3.56, it's 3 and 56 hundredths. Well, 3 and 56 hundredths as a fraction would look exactly like that. That's how you'd read this, 3 and 56 hundredths. So if you know how to read a decimal properly, that is one way to do it. Just read it, 3 and 56 hundredths, 3 and 56 hundredths. But the way that I usually do this is, well, first off, this whole number 3, it's still going to be a whole number 3. And the way you change this second part into a fraction is you take these numbers, 56, put it on the top part of the fraction. On the bottom part of the fraction, put a 1 and this many zeros. Since there's 2 numbers up top, you put 2 zeros down below. Sounds kind of weird. Let me give you another example. If you had 1.6, well, whole number 1, put the 6 on the top, and since this is only 1 digit long, you put a 1 followed by 1 0. If you had 2.352678, and if that's a terminating decimal, it stops right there. If we want to write that as a fraction, 2 would be the whole number. You put this on the top, so 35268. And since there are 1, 2, 3, 4, 5, 6 numbers on the top, you put a 1 followed by 1, 2, 3, 4, 5, 6 numbers on the bottom. Every one of these examples, if I would take this and divide it on a calculator, 56 divided by 100, 0.56. Clear. I'm going to do this one. 6 divide 10. 6 divide 10, 0.6. Clear. 35268 divided by 1 followed by 6 zeros. 1, 2, 3, 4, 5, 6. 0.352678. So in every case I've shown you, if you take a 1 followed by that many zeros on the bottom, that will give you your terminating decimal as a fraction. And this works for terminating decimals. Now, for repeating decimals, it's almost the same trick. So you take the whole number and you put it out front. You find out what's being repeated. In this case, it's 29. You can scribble all these other guys out, and it's just 1.29 repeated. Put them back so you can see. But that's what it is. It's 1.29292929. So you find the thing that's being repeated, it goes on the top. Now, instead of putting a multiple of 10, see, 10, 100, that's a million. Instead of putting a multiple of 10 on the bottom, you're going to put something like 9 or 99 or 999. In this case, because there are two numbers on top, I put 2 9s down below. Let's check. Mr. Calculator says if you take 29 divided by 99 equals 0.29292929929 forever. So that's how you're going to do every single repeated decimal. If you would have 3.8 repeated, 3 and 8 on top, there's one number on the top, so 1 9 on the bottom. These two are exactly the same. So, you now know the tricks. Let's see if you can do some on your own. So I'd like you to pause the video, try these 3 problems out. When you're ready to continue, hit play, and we'll go through them together. Okay, so hopefully you finished these 3, so let's check. The first one here should be 1 and 22 over 100. It's over 100 because remember it's 1 followed by 2 zeros because this is terminating. Because it's terminating, you use a power of 10. 10, 100, 1,000, 10,000. This one is repeating. So we're going to put it over 9s. And actually, I should have looked ahead because that's similar to what we did here. So 1.8 becomes 1 and 8 over 9. And calculator says 8 divided by 9 equals 0.88888888888. Ignore the 9 at the end here. That 9 at the end is because the calculator rounds. And whatever calculator you're using probably rounds that as well. Most of them do. Lastly, letter F. To turn this into a fraction, you simply put it over 1. So terminating decimals get put over powers of 10. Repeating decimals get put over a version of 9, 99, 999, a whole bunch of 9s on the bottom. And then whole numbers, positive or negative, you simply put over 1. Now what about the reverse? We've shown that every single rational number can be written as a fraction, but most of the time what you're going to see is having numbers as fractions can sometimes be more difficult, especially if you're trying to compare them, saying which one's bigger, smaller, because with fractions you need to have common denominators, and that's a pain in the butt. The best, easiest way eventually when we compare fractions is to have them as decimals. So that should tell us that every single rational number can also be written as a decimal. And it can. So here, honestly, it's kind of calculator work. I mean, 9 divided by 3, you don't need a calculator for that. 9 divided by 3 is 3. Now, if you want to make sure you know the decimal, it's 3.0. The whole number 3. Over here. 1 and 2 ninths. Now we can use the same trick as before. Remember how if it's over 9, it's going to be repeating the thing on the top? So this would actually be 1.22222222 or 1.2 repeated. And you can check the calculator. 2 divide 9 equals, there it is, 222222222. So just use the same tricks I showed you and taught you, but do them in reverse. Recognize it as a fraction and then know what it would look like as a decimal. Go ahead and try this one, letter C. So -2/5. Try to write that as a decimal. Pause the video if you need to. When you're ready to continue, hit play, and we'll go through it together. Alright, so what you should have, let's see, if you divide, or if you do a long division or divide on the calculator, you're going to get a negative 0.4. And that's what this would be as a decimal. Okay. Try letters D and E as well. So you're going to take these numbers and you're going to write them as decimals. Go ahead, pause the video, do these two prompts. When you're done and you're ready to continue, hit play, and we'll go through them together. Okay, letter D. Let's see. Well, if you take 12 divided by 3, you actually just get the number 4. So as a decimal, you could say 4.0, I suppose, or just 4. It's a rational number. Letter E. Well, we can do this using a calculator without any problems, but I want to try this one by hand. Let's see, I know my times tables of 6. 6 goes into 14 2 times. With a remainder of 2, the denominator stays the same. So when I do this, it's going to be 2 point something. And if you don't have a calculator nearby, if you have to do this by hand, it's just a long division. So the top number of the fraction goes on the inside, the bottom number goes on the outside, add a decimal, add some zeros, and just go to town on this thing. So 6 goes into 2, none. 6 goes into 20, 3 times. 3 times 6 is 18, and subtract, and bring down. And repeat. 6 goes into 20, 3 times. 3 times 6 is 18, and subtract, and bring down. Noticing a pattern? It's just going 20, 20, 20. So this is a repeating decimal. 2.3 repeating. Yeah. I just want to make sure I put my repeating bar at the top here. So 2.3 repeating, that's what 14/6 would be as a decimal. So we were able to show this rational number as a decimal in each case, and it's just going to be a division, either dividing on the calculator, Mr. Calculator, 14 divided by 6 equals 2.3 repeated, or dividing by hand using long division, maybe simplifying it first into a mixed number. Whatever you have to do, that's what we would do. Now, if you look at your note sheet, the next few problems, I think about 4 of them, are all going to be applications. You're going to see a lot of applications throughout these lessons. In each lesson, I try to include 3, 4 applications, word problems. Don't get yourself bent out of shape with the word problems. All you have to do is read the problem and try it. So we're going to walk through these a couple together, and then I'll have you do a couple on your own. Sam has the number 13/19, which when written as a decimal is that big ugly thing. Okay? Sam does not know if this number is rational or irrational. How would you explain to Sam if this number is rational or irrational? Well, this number here looks pretty bad. I mean, just looking at this piece, I would have to say this part makes it look irrational because I don't see anything being repeated. I don't see it stopping anytime soon. But you can't jump to conclusions yet, because this is how the number started. Is that a fraction? Can you write that thing as a fraction? Well, heck yeah, it starts out as a fraction, 13/19. So 13 over 19 obviously can be written as a fraction because it is a fraction. See, there's that. I just divided on the calculator. 0.684210526315789.5. but it has to be a rational number because it started out as a fraction. It started out as 13 divided by 19. So this number is rational because it can be written as a fraction. All that we know is the division of this. If you divide using the calculator, all we know is that the calculator doesn't know where it stops, or the calculator runs out of space. It might stop one number past what the calculator shows, but it does stop somewhere, or it does have a repeating pattern somewhere. That we can tell you for sure because it is a fraction. So I would say, how would you explain to Sam this number is rational or irrational? The number is rational because it can be written as a fraction. So it can be written as a fraction, and I would even put the fraction. 13/19. Be specific. Don't just say, oh, it can be written as a fraction. Show me what it is. So this problem wasn't too bad. It might have been a little tricky if you didn't remember about it started out as a fraction before you divide it. Okay, let's try our second example here. It says, the square has an area of 45 feet squared. Okay, so we're talking about a square. First thing I do, I draw a picture. So the area of this thing is 45 feet squared. Okay. The length of each side would be blank. Must be a typo here. Let me figure out what it should be. How about that? It says the length of each side of this square would be square root of 45. We want to know, is the length of each side of the square a rational or irrational number? So if each side is the square root of 45, so this side has a length of square root of 45, and same thing with this side, we want to know, is this number rational or irrational? Well, the way I would check is I would plug it into a calculator. I want to know, if I take 45 and square root that thing, that gives me an ugly number. So, as far as I'm concerned, that big ugly number is a irrational number. I don't see a repeating pattern, it doesn't stop, and remember, if you take the square root of any number and it doesn't come out to something perfect and pretty, like 3 or 5 or 8, it will be irrational. So, square root of 45 is irrational. So is the length of each side of the square rational or irrational? It is irrational. Because the square root did not come out to a nice pretty number, it will be irrational. What I'd like you to do is I'd like you to try letter C. It says come up with 2 rational and 2 irrational numbers between 3 and 4. Pause the video, try the problem. When you're ready to continue, hit play, and I'll come up with some of my own examples. Okay, so let's see what numbers you came up with. I came up with numbers like, for my rational numbers, I came up with things like 3 and 9/15 and 3.25. So I have one fraction, one decimal. They're both rational numbers. They're both between 3 and 4. For irrational, I came up with numbers like 3 point, and then you just make up some stuff. 3, 8, 2, that's a 9. 9, 2, 6, 3, 8, 5, ... So that as far as I can tell, doesn't stop, doesn't repeat. It's irrational. Another number you might not have thought of, but the square root of 15 would be irrational as well. And it would be between 3 and 4. So, better calculator. Here we go. So if I take 15 and square root, 3.8729833, and it does keep going forever. It doesn't stop. It doesn't repeat. It is irrational. So these are just a couple examples you could have come up with. There are literally an infinite number of examples for both rational and irrational. Last example here says James has to use 2/9 cups of flour to make a small cake. Is this number rational or irrational? What is its decimal expansion? There's a typo there as well. EXPANSION. What is its decimal expansion? So go ahead and try the problem. When you're ready to continue, hit play, and we'll go through it together. Okay, so first thing you should have found is obviously this number is rational. So 2/9 is rational. We know it's rational because it is already a fraction. Anything that can be written as a fraction is a rational number. Now, as far as what is its decimal expansion, the decimal expansion would be 0.22222 repeated. It's written slightly easier, slightly more proper. It's just 0.2 repeated. And you can figure that out using a calculator. You take, clear, 2 divide 9 equals, and there's a repeated decimal. Lastly, summarize. In the summary box, can you explain what is the difference between a rational number and an irrational number, please? So write a sentence, a small phrase. Go ahead and do that now. And if you haven't come up with yours yet, go ahead and do it now. But here's what I came up with. A rational number is any number that can be written as a fraction. An irrational number is any number that cannot be written as a fraction. So to see all of my lessons I've made for this year, you can go to www.seanhenry.org. There are all the lessons available with activities, more explanations. So we just did this particular lesson. There's worksheets. There'll be the YouTube video that I'm doing right now. The summary of the lesson, the places to check if you need more help, if you need more examples. So make sure, if you have any questions, feel free to ask. And I hope you had a good lesson. Thank you very much for watching. Bye-bye.